Hello and welcome again to Safety Short Series. Now today we will be posting 25th video of the series, and today's topic is on respiratory protection, and that is about identification of respiratory hazard. Now the air we breathe is mostly oxygen and nitrogen, right? But that's not all. It still contains a trace amount of harmful gases, smoke, vapor and dust produced by Mother Nature and by us. Now, fortunately, our lungs have a series of mechanical and biological barriers that keeps us, keep such contaminants away from harming us. But healthy lungs are not invincible. With repeated overexposure of toxics, these protective barriers break down, resulting in irritation, discomfort, or diseases. Unfortunately, we may not even be aware of the level of damage until it's too late to recover. What we breathe in workplace or the exposure we get, yes, we are talking about some terms related to breathing like black lungs, farmer lungs, asbestosis, silicosis. You have probably heard these work-related respiratory diseases and know of their consequences. These are just a few of the medical conditions that results from workplace breath contaminated air. You know, however, protecting workers can be difficult because there are so many types of contaminants and there are no single method for controlling them in the workplace. So today we will be discussing how to evaluate the hazard and how to control them. And it describes what employers should know before their employee use a respirator. So we will try and talk about basic type of respirators, what you need to develop or effective respiratory protection program, the essential requirements of OSHA respiratory protection standard, that is 1910.134. 1910.134. The standard specifies what you must do to ensure that your employee use respirators safely and responsibly. Now this you can refer basically. We'll be talking about the respiratory hazards and all. Correct. So this is we will not be talking about the different types of respirator, but yes, we will be definitely talking about the respiratory hazard, how to identify it and all that. Correct. So let's take it. So respiratory hazard. First, respiratory hazard include harmful substances and below normal concentration of oxygen in the air we breathe. What makes a substance harmful depends on its toxicity, chemical state, physical form, concentration, and period of time one is exposed. And what are examples of it then? Now, we know that respiratory hazard includes particulates, gases and vapors, and biological organisms. How this hazard effect is called its harmful effect. Yes, harmful effect are of wide ranging. It may occur immediately, which is toxic in terms and is said to be acute effect, or can take years of exposure to take years to develop, which is referred as chronic effect. So hope you are clear about the acute and chronic concept. Correct. Now let's take example. A respiratory hazard basically are categorized in three parts: particulates, gases, vapors, and biological organisms. So let's talk about particulates first. So what are particulates? Particulates basically these are airborne particles such as dust, fibers, fumes, mist, soot, and smoke. Some are so small they cannot be seen they cannot be seen with an electron microscope also. So the diameter of the particulate is usually measured in micrometers. 1 micrometers equals 1 by 1000 millimeters, correct? So particles with a diameter under 10 micrometers are more likely to enter the respiratory system. Hence, we say the rise concern why there is always a concern. We talk of PN10 and PN2.5, correct? So these level, hope this refreshes the memory, right? So now the second most important type of respiratory hazard is gas and vapor. Now gases can spread freely in air. Vapors are the gaseous state of substances that are liquid or solid at room temperature. Now gases and vapors are classified by their chemical forms. And finally, the biological organism. These include bacteria, virus, fungi, and other living organisms that can cause respiratory infections. Now let's add one more part to the hazard that we are discussing, and that results in oxygen deficient atmosphere, correct, or oxygen enriched atmosphere. Now normal air has an oxygen concentration of 20.8% of volume. So there is a misconception, like people say normal air concentration 19.5. No, it is not normal air. Normal air concentration, oxygen concentration is 20.8% by volume. When the concentration drops below 19.5%, the air oxygen is deficient and considered immediately dangerous to life and health. That is IDLH. Remember this term. For whenever you are referring toxicology or any hazard specific to respiratory hazards, you will surely come across this: immediately dangerous to life and health, IDLH. So there is an IDLH chart also. So the harmful effect of oxygen deficiency includes impaired thinking and coordination, and concussions, and sometimes death also, correct? So now let's discuss about conduct hazard analysis. So the 4-step hazard analysis process will help to protect you and your co-workers with respiratory hazard. The 4 steps are very simple, and they include at a very conceptual level things. So first is identify hazard, that is identify the respiratory hazard in your workplace. Analyze, use safety data sheets, SDS or MSDS, material safety data sheets, and other data to understand the nature of exposure. Evaluate the exposure to determine and identify the exposures are higher than the safe levels. And finally, control exposure by use of evaluation information to reduce exposure to the safe level. Now, simple enough, although it seems, but it's one hell of a task. So let's take it step by step to formulate some questions we can use as checklist. So starting by identifying the respiratory hazard, how we do it. Understanding this step is very important. For once identified, it can be analyzed, evaluated, and controlled. To identify air contaminants that may be hazardous, conduct observation, inspection, and interviews. Now, these methods help identify the source of respiratory hazard, such as a production process, a work task, a raw material, and even a final product. So at which stage the contamination is actually going to affect you, you should first analyze each individual. So how you'll do that? You'll first start with the observation. So observation conducted during the workday can be effective if employee take the time to observe condition and work. Without observation, it is not possible to trace any abnormal condition, for it's not necessary when the supervisor comes, same working condition under inspection comes, which is our second effective way of identification, that is inspection. So inspection are effective in detecting hazardous conditions, but not as effective in uncovering unsafe behaviors. With superiors or in charge taking rounds under observation, only you identify basic unsafe behaviors or act, individuals are working in the area and doing right. With inspection, the condition arises and identify and further analysis as well. Now, lastly, one of the known technique is interviewing individual getting affected. Now, interviews can be quite effective in gathering information if employees are asked open-ended who, what, where, how, and when questions. Now let's formulate some questions. We know it's always open-ended questions, so you should know what are those. Correct? So, who is most likely to be exposed to air contaminant? So this should be the question that you have to ask to the supervisors. What raw material are used in the production process? What are the immediate products and the byproducts of each process? What equipment or substances used by the employee might create an unacceptable level of exposure? What are the safety and health concerns employees have about certain product, material, or machines? Where do air contaminants exist in the workplace? How may air contaminants affect productivity of the workplace? When the air contaminant most noticeable during which work, during which period of work, in the entire day. So when employee experience or report signs or symptoms of respiratory conditions. So have employees experienced such things? So all these are open-ended questions. The most effective strategy to identify air contaminated hazard in the workplace is to integrate all three methods at once. So you need to have strategies to observe, to inspect, and to interview people as well. Correct. Now, finally, when you have already identified, the second step goes to analyzing the respiratory hazard. Once respiratory hazards have been identified, it's important to analyze each air contaminant to determine the type of exposure that they present. Now, understanding specific hazard to each respiratory hazard can be the best be accomplished by checking related to the safety data sheets or material safety data sheets, SDS or MSDS. Now, how we will evaluate the exposure? So we have to analyze. So we will be only able to analyze if the identification is done properly. So if once the identification happens, you have the list of MSDS and SDS, so you know what type of protection is to be done, what type of, how much exposure is permissible and all that. So that analysis is done. Now once the analytical part is over, we start evaluating the exposure. After you have gained good understanding through identification and analysis of the air contaminants in your workplace, it's important to evaluate each air contaminant to see if the respiratory protection is required. To evaluate the impact of employee exposure, trained specialists such as industrial hygienists gather data about the actual exposure and compare those measurements against OSHA's established permissible exposure limits, PELs. Test data from the sample and average over period of time, usually 8 hours, and referred to as time weight average, TWA. So air contaminants must not exceed the established permissible exposure levels, that is PELs, for 8 hours, TWA, that is time weight average. So this means you cannot do it on your own, and it is not so. Now gathering data is accomplished through one of the three standard monitoring methods. So what are those methods? If you know, then you will not face trouble, or you will not face impossible task. So the very first aspect comes to personal exposure monitoring. Now, measure the exposure of individual employee by sampling their breathing air. So there is a breathing zone near your face up to neck region. So that is the breathing air zone. So you just need to monitor through a personal air monitor. You can start monitoring and sampling the data. This procedure is most accurate way to evaluate exposure levels. This is the most accurate way. Now another way is area exposure monitoring. Now sample the air at specific locations to estimate exposure affecting group of employees. This method is useful when employees move about and may not always be near the area or source. And the third method is representative exposure monitoring, that is used when representative exposure data from industry, when we use representative data of the industry, that is from trade association or product manufacturing, or estimated exposure affect the group of employee. You must be able to show that the data are based on conditions similar to those that exist in your workplace. So that is the most least effective part of the program. If you as an individual professional want to do it, prefer area exposure. You must identify which area there are higher number of people and where there are most likely chance of exposure. If your company permits, then go for individual or personal exposure as well. Now, for most of the professional, the industry would, you would know this from environment data is submitted monthly and annually to the authorities. If you strategize this, it becomes easy to identify, analyze, and evaluate the exposure. Now, when we seek information, well, you will from where you will get this information of permissible exposure limits for specific air contaminant. Well, you can refer OSHA standards 1910, 1000, Table Z1, limit of air contaminants, Table Z1, limits of air contaminants, Table Z2, that is toxic and hazardous substances, and Table Z3, mineral dust. You can refer this for further information, from where here you will get most of the information that is required. So don't be surprised by looking at those information, but you just refer them for your better understanding. Now finally, let's talk about controlling exposure to respiratory hazard. Now, to eliminate or to reduce the chance of getting hurt in a workplace, employees use prioritized set of hazard control strategies called hierarchy of control. The highest priority strategizes attempts to eliminate, replace, or use engineering to manage the hazard itself. The lower level strategies work to reduce the exposure by controlling workers' behavior. Let's take a look at some of those strategies, right? So, eliminating and substitution. If employees are exposed to respiratory hazard at unsafe levels, you will need to determine how to protect them from overexposure. You might try to completely eliminate the hazard by using another production process or material that are not hazardous, substitute or replace the hazardous substance with less hazardous substance that does not require much protection. Now let's take an example of this. Let's understand with an example. For instance, when performing an abrasive blasting, the worker might replace blasting sand, which contains silica and abrasive media such as grass beads and corn and cob, by air and dry ice. So there is, so you just replace the sand blasting with dry ice blasting. So we have simply replaced. There is no material little vaporized in the air. So there is We have replaced it, correct? So this is the elimination. Okay, say this is not possible. So next strategy comes to engineering control. If you cannot eliminate, replace the respiratory hazard using engineering control to lower exposure levels or safe levels. Such control or engineering or physical change the working environment so the air is safe to breathe. Now, example of engineering control include isolating the production process so that the employee are not exposed, insulating the exhaust hoods to remove air contaminants, or installing an exhaust hood to remove the air contaminants, using wet methods to reduce the exposure of airborne dust, integrating dust collection system into cutting and grinding equipments. So these are all engineering controls. Now let's talk about the administrative control and respiratory protection. Now administrative control establish programs and policies that require employee to use processes and procedures and practice to help to limit exposure to hazardous substances. As you can see, the primary strategy is to control behavior to limit exposure. Now, some example of administrative control relates to the respiratory protection includes requiring employee to use respirators when working with any particulate or any place where exposure is possible, conducting hands-on training on use of respirators, establishing rules to take care and maintenance of repair, and mandating the medical examination of all employees who will be using the respirator. Now, employee must use respirator for protection from respiratory hazard when engineering controls are not feasible or will not reduce their exposure to safe levels. Now, here I would like to discuss one more aspect, that is assigned protection factor, that is APF. Now, assigned protection factor basically means the workplace level of respiratory protection, that a respirator or a class of respirator is expected to provide to employee when implement a continuing effective respiratory protection program. For higher risk exposure situation, that is higher concentration of infectious particles, choosing a respirator with a higher APF, that is assigned protection factor, provides a higher level of protection for the wearer. Now, APFs for different types of respirator are presented in table 1 of OSHA's Respiratory Protection Standard 1910.134. So you can refer that table, table 1 of OSHA's Respiratory Protection Standard 1910.134. Correct? You can refer that. Now, there is another factor that is called maximum use concentration, MUC. So maximum use concentration means the maximum atmospheric concentration of hazardous substances from which an employee can be expected to be protected when wearing a respirator. It is determined by the assigned protection factor and the respirator or class of respirator and the exposure limit of the hazardous substances. Be sure to select the respirator for employee that maintain their exposure to the hazardous substances at air below the MUCs, that is maximum concentration level. Do not apply MUCs to conditions that are immediately dangerous to life or health. Instead, they must use respirator listed from IDLH, that is immediately dangerous to life and health condition. Now, when the MUC exceeds the IDLH level for the hazardous substances or performance limit of the cartridge or canister, then set the maximum MUC at lower limit. Correct? Now, for more information, you can see OSHA's publication 3352, that is assigned protection factor for revised respiratory protection standard. You can refer to OSHA's publication 3352. Correct? So we were able to give you as much information on respiratory protection, specifically related to identifying the respiratory hazards. So thank you everyone for your support. Said Safety Shots is a series focusing on safety videos. Thank you for all your support. Keep liking and sharing, and do not forget to subscribe for our motivation. We'll keep posting more such videos. Till then, be connected and stay safe.